All right. Hi everyone. This video is going to be about some more advanced TypeScript APIs. You should only go through this video if you've gone through the TypeScript track, the TypeScript class before, because this won't cover too difficult of things. If I'm being honest, you might be able to catch up, but if you don't know TypeScript at all, then this will be a hard track. So make sure you know a little bit of TypeScript before proceeding. The first slide itself says some prerequisites. You make sure you've gone through the basic TypeScript class and you understand interfaces and types and how TypeScript is used in a simple Node.js application. If you understand the following code, you're good to go. If you understand, okay, we are creating an interface for a user who has a name and an age, name being a string and age being a number, a function called sum of age that takes two users and input as inputs and returns the sum of their age. You can call this with two users and then finally log the result. If you understand this, then you're good to go. If you can write this yourself, even better. So let's quickly try to bootstrap a project locally and try to write all of this yourself. You should write it yourself. I'm going to write it myself. Step 1 is opening a terminal. Creating an empty folder and then initializing npm inside. Initializing TypeScript and then opening this in Visual Studio Code. Once you do, update tsconfig.json with the root dir set as ./src and the out dir set as ./dist. Create an empty folder here, call it src, and initialize an empty index.ts file inside. This has been our standard bootstrapping mechanism for TypeScript applications. Now start to write some basic code. If you remember, we had an interface called user who had a name, string, and age number. Copilot helped me out here. Make sure you have it turned off if you're typing this for the first time. I had a function called sum of age, which takes user1 as an input, user2 as an input, and returns user1.age plus user2.age. And then I would call sum of age with two arguments. In my case, Copilot gave me two of these arguments. If I log this, then what do you think should come on screen? 50 should come on screen because the sum of 20 and 30 is 50. Try to write this yourself and then compile it. The way to do that, tsc-p or npx tsc-b. This would convert your TypeScript code into JavaScript code. So if you go to dist/index.js, you should see something like this. You never need to explore the JavaScript files, but just to see it from a high level, looks like this code of mine was converted into this code right here, and we're good to go. Now, if I run node dist/index.js, I see 50 is logged on the screen, which basically tells me my code works as expected. I was able to write TypeScript code. I was able to compile it down to JavaScript, and I was able to run the JavaScript file. Make sure you're able to do all of this and only then proceed to the next slide, because in the next slide, we will start to understand some more extra things that you can use TypeScript for. Pick. This is the second API we're discussing today, or like the first API, I guess, on the second slide. Pick allows you to create a new type by selecting a set of properties from an existing type. Let's look at the example. Maybe let me explain this myself. Let's say you have a user in your database who has an ID, string, name, age, email, and then something that shouldn't be changed. Email probably, password. Let's say this is how you store your user in your database. So that's why you have a user interface, so that whenever your end user, whenever you do, a mongoose.get user, need a simpler syntax. Whenever you do user dot find one, where email equal to something, the value that you get on the left from Mongoose is of this type user. It has an ID, it has a name, it has an age, so on and so forth. You can also replace the thing on the right with PG, which means Postgres. Doesn't matter in the end. Whenever you do a database call, you get back a user which is of type this, which has an ID also, name, age, email, and password. But let's say I ask you to create a function called update user, which needs to, hit the database to update the user. And given I tell you कि you can only change the name, age, and password. You are not allowed to change email and ID once the user has initialized. So the arguments that you accept here could either be this. You could have name, age, and password. But what is the problem here? This works. Your function can totally have 3 arguments that look something like this. But the problem here is, if this grows, then so do the number of arguments. And the general rule of thumb is every function should not have more than 5 or 6 arguments. The way the function looks gets very ugly if you have too many arguments, which is why you need to merge them together. So you might be like, Harkirat, I will do this. Updated props, and then I will define a new interface called update props, which will have just the name and the age and the password. That way I can say the type of update user is update props, or the argument of update user is update props. This is good, but what is the problem in this? Can you figure out why is this slightly bad, and why do you might want to reuse this somehow? The answer is, what if you change the type of age from number to string, let's say? Then you have to change it in 2 places. And it's easy for you to miss that you have to change it in 2 places. Ideally, if this is your single source of truth, this is what the user looks like, you should be able to pick properties from it. You should be able to say, okay, dude, update props isn't something new. It is a subset of these. And the way to do that is using pick. You can be like, type update props equal to pick from the user's object just the name, age, and email. If you write this code, now you're using the user object and pulling out some properties from it, pulling some properties from it, picking some properties from it. That is what pick lets you do. The syntax is a little weird. It is a generic that expects 2 arguments, the user generic and what all properties you want this specific update props to pick. So might feel a little weird कि हाँ कि we're more comfortable with the functional syntax, but in the end this is a type. This is not a function, does not have a runtime. So whenever you usually do sort of function calls in TypeScript, you're not really doing function calls, you're using a generic, which is why you'll see this very often even throughout today. Okay, whenever you're using one of these APIs that I'm introducing today, you're using generics a lot. And if you don't know what generics are, we've covered it in the TypeScript week. This is one way to use generics to pick values from this. Now if I hover over this, you will see it has a name, age, and email, which is exactly what this specific function expects. Cool. That's the first API. Try to write it yourself specifically. Get comfortable writing this syntax. Pick, the first argument being what you want to pick from, and the second argument being all the properties you want to pick, separated via an OR. Cool. That's the first API for today. If you look at the code, I do pretty much something similar. This guy had a name and an email, and that's what we pick here, and that's what we pass on to the update users function. And here we're just logging something. In the real world, of course, there would be a database call here, but just because we're understanding pick, we've only focused here rather than focusing on the body of the function. Cool. Try this out yourself before proceeding to the next one. What is the first one we have learned? Pick, that lets you select a set of properties from an existing type. Harkirat, this is not type. You said it lets you pick from an existing type. This too is an interface. This is not a type. Both. It lets you pick values from not just a type. It lets you pick values from an interface as well. Cool. That's the first one. Code is right here. Feel free to try it out on your side. The second one is partial. I think I forgot to write some code here, but we can write it together. Partial makes all properties of a type optional, creating a type with the same properties, but each marked as optional. Basically, if you have a type that looks like this, where name is required, email is required, and image is required, and if you want to convert it to a type where name is optional, email is optional, and image is optional, what you would do is use a partial. The name itself says partial, which means select partially. A good real world example of this is we already have this update props, but it expects all three of these to be present. If you have a user in the real world, they might not be updating all three, right? They might just be updating the name, or just be updating the age, or might be updating both name and email but not the age. So ideally, should update props expect all three of these, or should it expect कि भाई give me any one of these, it is fine? Should all of these properties be optional in update props? And the answer is probably they should be optional. A user shouldn't be expected to give you all three of these values. If in the end, you have a express route app.get or whatever app.put that looks something like this, and you have update props here, it isn't necessary that the user gives you all three. The user might give you just the name, the user might give you just the name and the age. So how do I mark all three of these as optional? Harkirat, you can either create a fresh type, so you can not pick and do the same thing we were doing before. Okay, name optional, age, and then password optional. You can either do this, or again, the problem here remains the same. If you change something here, you need to change it here as well. So what you can do is first pick the values that you need and then create a type update props optional, which is ChatGPT is helping me out too much. I should flip it off, but you get the idea. Update props optional says I want to partially select values from here, which means if you hover over it now, all three of these have been marked as optional. Now the user can give you name if need be, cannot also. This function argument doesn't necessarily complain if I just give it, a name. As you can see, no TypeScript errors. But if I replace this with update props, then I see TypeScript errors. It says you need to give me all three of them. So if you want to allow optionally passing all three of them, what is the best way to do it? You can use partial, which marks all of the keys as optional. Now if I remove this, does not matter, TypeScript does not complain. Remove this, does not matter, TypeScript does not complain. I can also remove the last one as well, since all three of these have been marked as optional. Cool. That is what partial lets you do. All right, next up, let's understand read only. This one's interesting if you've ever thought of this problem before. A lot of people asked me, Harkirat, if I do something like this, right, const user equal to name Harkirat, age 21, and then if I try to update the user.name equal to something else, it lets me do it. Even though user is a constant, still I'm able to update its properties. Have you ever asked yourself this question? The same applies to an array. If I create an array const a equal to 1, 2, 3, I can actually update a. I can do a of 0 equal to 4. And TypeScript does not complain at all. Let's just focus on this example. I have declared an array which is a constant, and yet I am able to update a property on it. I cannot do that for a string. If I do const name equal to Harkirat, then try to do, why is this? Let's const username equal to Harkirat, and then if I try to do username equal to something else, TypeScript begins to complain. It says cannot assign value because it's a constant. But the same doesn't happen if I do it on an array or an object. Why? If you can see here, create an array, update the value, is able to do it. The reason is you can always update internal values of an array. You are not changing the reference of A. A is still the same. You were able to add values to it. You can push values to it. You can change the values in it. You are not changing A. You are changing the values inside A, which is why you can, this is a very bad way to explain it. It's basically you're not changing the reference of, I'm not doing this. a equal to 234. If I do this, is when TypeScript begins to complain ki haan, you're trying to change the value of a, but if you try to change a value inside a, that TypeScript won't complain about, or even JavaScript. That you can do both for an array and for an object. So if I have an object that looks like this, then I can do a object of dot name equal to something new. Nothing will change. What can I not do? I cannot do this. I cannot reassign object the whole thing. I can reassign a small inner value inside. TypeScript or JavaScript won't complain on that. But what if I want to enforce, okay, I don't even want this to be changed. I want to enforce that neither the object can change, neither can an internal value change. How can I enforce that? That is what read only lets you do. The name itself says read only. If I define a type, let's say type user equal to name string, age string, and I make them read only. So I prepend them with read only. Now if I create a new user of type user, give it a name and an age should be a number. And now if I try to change either the name or the age, it begins to complain. Why? Because I mentioned that the inner values are also readme. So I want TypeScript to complain when either this changes or this changes. That's how you can enforce constants on internal values. If I don't do this, then TypeScript won't complain. It will be like you're not changing, sorry, it should be user and not object, but you get the idea. If I have user here, it'll still complain. It's saying cannot assign to age because it is a read only property. Versus if I make this non-read only, then TypeScript does not complain. So when you want to enforce okay, all the inner values are also constants, is when you should use read only. And if this syntax seems very ugly, ki yaar, I have to write read only again and again, what you can do is this. You can be like, none of them are read only, but the whole object is read only, like this. If you do this, that is equivalent to you writing read only again and again. Cool. That is what read only lets you do. It lets you enforce okay, the internal values of an object. Also, you're not allowed to change during TypeScript compilation. If you do that, TypeScript will complain. Your code will not complain. It will tell you, okay, you cannot reassign to age. What is a good use case of this? The thing that I've shared in the examples. Okay, if you ever have a configuration variable, a config variable where you're storing, okay, this is the API endpoint of a different service. For example, ChatGPT. If you're ever creating a ChatGPT wrapper, if you're ever using the ChatGPT API, you want to make sure that user by mistake, a developer by mistake, doesn't update config, doesn't update the API key. And so you can enforce that by marking it as read only. You can be like, you don't need this because you're using read only here, or you can not use read only and only use these. Both of them work. You can enforce कि हाँ भाई, now if by mistake also a developer who's writing the code in this TypeScript code base tries to update the API key, they won't able to. The project itself won't compile because you've marked this as read only. If you don't mark it as read only, is when a developer can by mistake update the API key, which is something we don't want. Cool. That is what read only and capital R read only let you do. Let's move on to records and maps. Next up, we're discussing records and map, which are just an easier way to deal with objects, or maybe a cleaner way, maybe not easier. Let's understand how you create objects in TypeScript first. Let's say I want you to create an object that looks something like this, a user's object, which has a key, which is the user's ID, and then a value, which has their ID again and a name. So how would you create it? It would be something like this. Harkirat, users equal to user with ID 1 has ID 1 and username Harkirat. Let's make this a slightly easier ID to deal with. and then maybe another user your database has, which looks something like this. Cool. You have two users. They have different names and they have different IDs. What is the type of users? Can you guess? If you look at it, you can define the type of users currently like this. You can say, okay, my user has a type that looks like this: ID string, username string, which is basically this right here. And users is an object which has key, which is a string, and value, which is a user, which is this thing right here. Can you copy this from here over here? Yes, you can do this as well, or you can do this. Both of these work. In the end, you have a very nice type for users, which is an object which has string as a key and ID username as the value. This is, it might seem very complicated. This is like the easiest way to do objects in TypeScript. If this seems complicated, you can do this. Let's say we don't even have users as an object. You have something like this. Hope that's easier. Okay, users is simply an object where the key is a string, which means how you index the object, and the value is a string as well. You could have another one called user's age, let's say, which stores the age of a user, and that might look something like this. Cool. That's how you give types to an object. But as you can see, it looks pretty ugly. It's not the cleanest syntax to deal with. And that's what the TypeScript folks realized. And hence, two things are introduced. One is a TypeScript specific concept. One is a JavaScript specific concept. Records and maps. Let's understand records first. Record lets you give a cleaner types to objects. You can type objects as follows. This is the ugly syntax. Or you can use a record, which, as you can see, the syntax looks something like this. This is a cleaner syntax than what we had right now. Right now, the object looks pretty weird, very hard to read, versus this is pretty easy to read, right? Okay, users is a record, the key is a string, value is a number. Compared to user's age is an object where key is a string and you have square braces here, colon number. Which one of these looks cleaner to read? The second one, which is why usually you will see, almost always you will see record being used everywhere and not this ugly syntax whenever you have objects. Cool. So if I paste this here, it still works, and you have a much more cleaner syntax to create objects or types of objects. You can also make this more complicated: age, number, and name, string, so on and so forth. So, age, number, name, Harkirat, age 33, name, something else. Cool. Good question at this point is, Harkirat, is this a JavaScript thing or is this a TypeScript thing? You can always check by compiling the code. If you compile the code and if the final index.js file, you don't see record, it means it's a TypeScript thing. It's only something that the TypeScript compiler understands. It is not something that you can paste in a JavaScript console or in a JavaScript file. It will tell you record does not exist. But TypeScript does understand record, and it's just a cleaner way to create objects. Cool. That's what record is. What is map though? This is not a TypeScript concept, but a JavaScript concept. So you don't necessarily need a TypeScript file for this. This is KR. It's very difficult or ugly to do a users of, this thing dot age equal to 233. If I want to ever update it, or if I want to ever get it, this syntax works, the object syntax works. But what if you could do something like C++? What if you could use maps, which is a very common syntax in C++ if you've done it before, and it looks something like this. Okay, you can be like, const users is no longer an object but a map. So const users equal to new map, and then you can give it a type if you're using JavaScript, you will not use a generic here. So this will just work. You don't necessarily, this is good. You can always be like const users equal to new map, and then be like users dot set the first user, and then similarly users dot set the second user. So let's keep it simple right now. We initialize a new map and we set values here, similar to how we used to do users of something like this. We used to do something like this, users of this something equal to an object. Rather than using this syntax, if you are creating a map, you will use users.set, and similarly to get back a value, you used to do users of something. To get back a value here, you would be like const user equal to users.get the ID of that specific user. This is just another syntax to create key value pairs. You can either use an object, you can be like const users equal to an empty object, or you can be like const users equal to map, and then you can set on the map, you can get on the map, you can delete on the map, so on and so forth. Cool. So does that mean, okay, is this a TypeScript concept or a JavaScript concept? That's probably the first question. And the answer is this is a JavaScript concept. If I copy all of this, let me also log user here. If I copy all of this code and either paste it in the console here in the browser, you will see I do see user get logged. If you focus on the code here, it creates a map, sets two values, gets the value, and then logs the user. So it does work without TypeScript. If I also compile the code, you will see the final JavaScript file does have a map, which means it's not a TypeScript concept, it is a JavaScript concept. It's just another way to do key value pairs. What are key value pairs? Objects in JavaScript are a key value pair. Anything that has a key and an associated value, which here is the key is the username and the value is the specific object, is called a key value pair. Objects are a key value pair, and similarly map is another way to do key value pairs slightly easily, or like in a cleaner syntax with like a get, a set, a delete, so on and so forth. Very similar to how C++ lets you do it. If you understand this part, let me share one more thing. When you are generating the map, you can specify its type. You can here enforce, okay, bhai, the key for this thing needs to be a string and the value of this thing needs to be a user's object or user's type, which looks something like this. So what have I done? I've said that when I am initializing the map, I'm making sure that bhai, this is the type. The key needs to be a string, the value needs to be a user, so that if the user does not give me something, misses something, TypeScript begins to complain. So you might see this very often. Okay, you know, when you're initializing the map, you are initializing the value of the key value pair or the types of the key value pair. So don't get overwhelmed. It's basically just a syntax to specify, okay, this final user's object will have string as a key, and whatever the value might be, in our case, it's just a user's object. And now, until I have a full user's object over here, TypeScript will complain. And that's good because we want to catch errors like these in case I've missed email over here. Cool. That's records and maps, just another way to do what's called key value pairs in JavaScript and TypeScript. You can pick and choose which one you want to do. Ideally, I just use maps versus, you know, you'll see record in a few places. But again, if you're using record, you are still creating objects. And the whole point of moving to map is to have access to these .get and .set functions that make your code a little bit easier to read rather than, you know, doing this throughout your code base. So it's considered, okay, rather than doing this throughout your code base, doing this is slightly cleaner. This is a very developer specific choice as to which one do you think is more cosmetic. But generally I prefer this one, especially if you're coming from a language like C++. Maps make a lot more sense than, you know, objects. With that, let's move on to the next section, which is exclude. This one, thankfully, is again sort of self-explanatory, similar to pick, very similar but slightly different. Exclude lets you exclude a bunch of, call them strings, call them littles, from an original object. So if you look at the code right here, it says type event, which you should probably rename to something else because event is probably a reserved keyword. Type event type equal to either click or scroll or mouse move. So it can be one of these three values. And type excluded event excludes from this just scroll. What does that mean? That means it picks click as well as mouse move. So if you want to select two values or three values, or more specifically exclude values from a type, you use the exclude keyword or exclude type in TypeScript. And what does it let you do? It lets you exclude a certain literal, in this case, from a given type. So if the handle event function you call with click, which is what exclude event can be, it will work. If I call the same thing with scroll, which is something that I excluded, it will give me an error. That way you can, if you know you want to pick certain values, and more specifically exclude certain values from a given literal, you use exclude. Again, there are a lot of these. This one probably, sort of self-explanatory. I'm assuming if you see this in a code base, you almost immediately understand what it means. Okay, we are trying to exclude from the given types this, so I don't have to explain it again. Or like you'll find many such properties or types in TypeScript that I'm not covering right now, but are almost intuitive when you look at them. I think pick is another such type, which we saw a few slides ago, which if you look at it in an open source code base, you'll probably be able to just figure out, makes sense. I'm picking just the name and the email from here. Now pick and exclude might feel very similar, but they're significantly different. Pick makes sense in an object, and exclude we're doing when we have a bunch of literals that a type can be. Cool. Hopefully this one's straightforward and like you don't have to spend too much time here, but do try to code this and make sure you're able to get an error thrown when you try to call the function with something that you've excluded. Cool. With that, let's move to the most actionable one. Maybe by actionable one I mean the one that you'll use more often today, like in our journey, as we move to monorepos, as we create more strict Zod types. We'll see Zod, type inference in Zod, which is something we haven't yet discussed. So let me share what this is and a little bit of where we will use this in the future. When using Zod, we're doing runtime validation. We're doing runtime validation. For example, the following code makes sure that the user is sending the right inputs to update their profile information. If I copy this code base and paste it here, and then maybe run the following commands: npm install express at types/express and Zod, so that I'm able to bring all of these dependencies to my project. You will see what exactly does this code do. It initializes an empty express application. It defines a Zod schema. Basically, name, email, age are three parameters that the user can provide you when they're trying to update their information. So we have a put endpoint that the user can hit, where we check whether or not the user profile schema is what is followed in rec.body, whether or not the body that you have received from the user actually follows this schema. And what is the schema? Okay, the name can be a string with a minimum length 1, and if it is not of length 1, you should throw this error. Similarly, email should be a string, and if it does not follow the email format, then we should throw this error. And similarly, an age, which is a number which is at least 18, and if it's not 18, then you tell the user that there is an error. You have to be at least 18 years of age. Cool. This probably maybe something we haven't discussed, how you give error messages along with constraints. If that feels overwhelming, feel free to remove it, because the goal of this one is to understand type inference in Zod and not how to give error messages in Zod or cleaner error messages in Zod. But I hope it's pretty straightforward. You just have the second argument, which has the message that you throw the exception with, so that you have a cleaner message to understand as to why the validation failed. This works, and this is great. You check whether or not the body follows the schema, and if it does, you get the body, and then you do whatever you want with it. You probably hit the database, update the database, so on and so forth. If it is successful, if it is not successful, you early return. You tell the user you have a status code of 411. You'd send something incorrect. Your inputs did not pass validation, which is why you let the user know, we have not updated the user details. You've not sent us the right things. If they did send you the right things, the control reaches here. What is the problem? The problem is you don't have very nice types here. Update body is of what type? It is of type any. What should it be of? What should the type of this be? It should be something like this, right? It needs to be name string, email string, age, number, which is optional because age is z.number.min18.optional, which means user can or cannot provide it. We don't expect the user to give it. If they give it, then the validation works. If they don't give it, then also the validation works. If we have this, and it seems like it just works as expected, what is the problem here? I added a type here, and now update body has a type I can use. I can do a update body dot, and it gives me the 3 arguments I can get. So this is good. I was able to give a type to update body, but I have it defined in 2 places. I have the types defined here. I sort of also have defined the shape here. Wouldn't it be nice if I could infer this type given this Zod schema? I repeat, given that I've already written this Zod schema, wouldn't it be nice if somehow this could spit out type final user schema equal to this thing right here? Wouldn't it be nice if I don't have to write it twice, so that I don't have to do this, and I can simply do update user schema, somehow get this from this, somehow infer this from this, and that is what type inference in Zod lets you do. Let me take you through the slides, and there is a whole section on this website of Zod on type inference. And what does it say? It says you can extract the TypeScript type of any schema with z.infer type of my schema. So if you look at this syntax, what does it say? It says, let's say you say const a equal to z.string. Then you can say type a equal to z.infer, curl these braces, whatever they're called, and then pass in type of a as a generic. If you do this, you can get the type of a variable, or more specifically, get a type given a Zod variable. One very big distinction to know is this is a runtime variable. This is a compile time variable. I repeat, if I write, let's just write these 2 lines of code. Let's remove everything else. I have 2 lines of code here, and I will do a import z from Zod. This is a runtime variable, by which I mean, let's make this slightly better, a string type and or string Zod schema, and then let's make this string Zod type. If I compile this code and look at dist/index.js, you will notice it has string Zod schema, which is this thing right here. It does not have string Zod type. Why? Because this is a TypeScript type. This is similar to me writing type x and then equal to something inside. This never reaches JavaScript, and similarly this never reaches JavaScript. Zod lets you infer a type given a runtime variable. Given a runtime JavaScript variable that lets you do validation, you can infer its TypeScript type by using this syntax, by saying z.infer type of the Zod validation schema. So if I go back to our original project, rather than doing first defining the schema like this and then redefining the type, I can simply be like const final user schema equal to z.infer type of user profile schema. And that way I don't have to retype everything. If I make a change here, if I make this a number, then automatically this also has name as the number. If I make this a string, then automatically this also has name as a string. And I can use this right here. I have update body, which has very nice declarations. Cool. Now you might feel like this is a little too unnecessary, giving me the type over here, and it is. You can actually just extract data from here, which has the right types. But this becomes super important when we start to define the same types on the front end. I repeat, This is something we define on the backend. Zod is a library you will always use on the backend. Never will you use this on the front end. But you might need this type on the front end a lot of times. You might need whatever is the form that the user fills to actually update the user profile. That form actually has this type somewhere, so you can, figure out and make sure it's sending the right things to the backend. So this type, even though I've defined it here, it's not really necessary here. It's actually becomes very necessary when you actually export it from here and import it in the front end. Harkirat, how can I export something from the backend index.ts file and import it in the front end? We will get to this when we reach monorepos. If you want to do React front end and Node backend sharing code, and we will also get to this in Next.js when front end and backend just exist in the same repository. The thing to know is this syntax, which is how to infer types given a Zod object. Given a simple Zod object, doesn't have to be an object, could just be a string. If this is a string, then what is the type of this? It is string. If this is a number, then what is the type of this? It is a number. If this becomes an object, which has some keys, then let's remove this. And then the type of this also has name and string. If I make this optional, then the type of the second thing also becomes optional. Cool. So spend some time, define a few. Whenever we write the next backend in a complete application, we will use both Zod. We will infer the type. We will export this, and we will use this on the front end. So get comfortable with it. This syntax sort of overwhelms people the first time they're looking at it. Try to write this yourself. The thing to learn is z.infer type of the runtime Zod object that you had created. With that, let's end it. I'll see you guys in the next one. Bye bye.